Hi everyone. Hi. Sorry for this little delay in our live stream, but yeah, we are here 5 minutes after, and I'm thrilled to welcome you to another exciting edition of X Bytes, brought to you by our generous sponsor XGeeks. And as usual, I am your host Fabio Sampaio, community manager at XGeeks, and today's live stream promised to be extraordinary as usual. And yeah, you have the privilege to have with us today Jomar. Jomar, welcome to the stage. He is the developer relations manager at NVIDIA, and will be share more insights about that during his presentations. And he is going to speak a little bit about how to accelerate your AI applications using NVIDIA SDKs. And before we dive into the technical wonders that Jomar has prepared for us, I want to extend our thanks to him, of course, for taking up the challenge and contributing for the growth of our Xbytes community, this live stream. And just a quick shout out to our XGeeks, to our sponsor XGeeks, just also to thank XGeeks to be our sponsor. XGeeks, for those that don't know, is a software house of a major group that is KI Group. XGeeks is specialized in cognitive technologies, and they try to maintain a profound commitment to community building, and this dedication to the community. Is also demonstrated here in this live stream, in this monthly dynamic. But we also have 4 meetup groups. We also have our blog spots, our YouTube recordings, among other things. And if you want to follow us and to understand a little bit more our community-driven initiatives, I will advise to just click here in our link tree to know a little bit more about us. So that said, and without further ado, because you are not here to listen to me, but to Jomar, let's give the spotlight and the stage to Jomar, please. Jomar, the stage is yours. I will quit myself, and thank you again.
Thank you so much, Fabio, for the invitation, and also Otávio. It's a really honor to be here. Good evening for everyone. In this case, I'm talking from Brazil. It's still afternoon here. The idea today is to show you what I used to call the dorsal spine of NVIDIA SDKs for artificial intelligence. We have more than 150 SDKs, more than 500 libraries. Almost all of them are for free and open source. And sometimes it's hard to connect the dots and understand how the pieces match together. And this is why I've built this presentation. I plan to cover the most important areas we are working right now and our communities are working right now. So let's start talking about how NVIDIA works. Usually everyone knows NVIDIA because of our hardware, the GPUs, the CPUs, and the other stuff on hardware we produce. But the way we work over the past more than 15 years is that we really listen to the needs of our customers. And based on the need of our customers, we develop a full stack for them to produce what they want. I'm going to use Merlin as one example. It's one SDK that is here on the list. Recommendation engines is something that was developed and used over the past decades by the whole industry. But every time anyone needs to start a new recommendation project, they need to put together a lot of open source software stack, then build something on top of it. Then finally they have a basic engine and they can start working. And when talking about hardware acceleration, when you combine all those pieces, it's really, really hard to optimize everything to get the most of your hardware. So what we did, we talked to the key customers that use those kind of engines, and we listened to their needs. And then we developed this SDK that is open source, named Merlin. This SDK is based on three big platforms. Actually, this one is based on AI, but we have three big software platforms, one for HPC, one for artificial intelligence, the other one for Omniverse, that I'll explain what it is on the end. This is based on system software, that is RTX, CUDA, and physics. and they run on top of our hardware. Depending on the kind of workload we are working, on this case, recommendation engine, we need the one specific computer architecture or server architecture to host this kind of workload, because the hardware needs, the communication needs, the memory, the disk, the speeds, the latency inside the computer are totally different from a graphics application to a AI training application to a computer vision or to a recommendation system like this one. So sometimes we need to change a lot of those components to be able to deliver the most valuable SDK or tool to our developers, that our end users. So this is how we've built more than 150 SDKs over the past 15 years. And basically, when full stack of this is done, we open everything. So the hardware you buy from OEMs like Lenovo, Dell, HPE, Supermicro, and others, and all the software we give it away to the to our software ecosystems. So it could be startups, it could be individual developers. Software could be for free, or they could be open source, which is the case of the most important ones. Okay, this is how NVIDIA growth to the size we are today. We grow through our ecosystems. Developers are extremely important for us. Today, NVIDIA has more software engineers than hardware engineers, just to illustrate this. So without these ecosystems of OEMs, developers, startups, and software partners, we wouldn't be able to do that much of innovation over the past decades. I will start this talk talking about one of our frameworks that is focused on data science specifically. And it doesn't matter what you do with artificial intelligence. At some point, you need to process a huge volume, a huge amount of data. And this is why we developed Rapids. Rapids is an open source project. You can access more information here, rapids.ai, and you can find a lot of resources to learn, to explore, and even to run Rapids on cloud providers with free tier accounts to access GPUs there. And we developed Rapids to address those three issues. First, data science and data manipulation, when the volume is huge, it's time consuming. It's associated with it costs, not only hardware costs, but also people costs, because sometimes you as a developer put a network to train or put a machine learning model to train, you need to wait like 10 hours, 15 hours. And then when you realize that, I forgot this parameter, I could do this adjustment to the data set. And here we go again and wait another 15 hours. And it is frustrating for everyone working on those projects, from the data scientists to the developers and to the customers and people that are there waiting to see the value of what they're investing. So to address those things, we develop Rapids. And NVIDIA has solution for anything related to data science to be accelerated on our hardware. And Rapids is focused here on analytics, machine learning, streaming, and visualization. We all that work with data science, we learn at data science basically using PyData, such as PyData libraries such as Pandas, Scikit-learn, NumPy, SciPy, and others. They work very fine. They are very easy to work with, basically, but they were developed to run on what I used to call generic hardware, which means they are meant to run on CPUs, basically, and everything is done and built for that kind of environment. What we did is that we didn't reinvent the wheel. We created a set of libraries that has semantic and syntactic compatibility in most of the cases with those existing Python libraries. So we have, for instance, QDF and QAO that can do almost the same of Pandas, QML, QGraph, and several others. And the cool thing about it is everything is based on Apache Arrow. That is basically a way of arrange data in a columnar way. That makes a lot of sense when you are talking about highly distributed and parallel algorithms, which is basically what you do inside the GPU. This is really important because if I need GPU acceleration on a part of my data science OA or AI pipeline, I used to pay one big price every time I need to take the data from the RAM memory and put it inside the run memory of the GPU. This is the latency that I have basically due to physical constraints on the servers and computers. And sometimes if I use GPU just for one part of this pipeline, I would take more time bringing that or moving data back and forth instead of processing. So the ideal scenario when using acceleration like a GPU is that you run almost the biggest part of your algorithm or your pipeline without leaving the GPU. Ideally, I just bring the data on the beginning of the processing, I do the whole pipeline on the GPU, and I return it. And this is what we do with Rapids integrated with Apache Arrow. To start with Rapids, you need just a computer with an NVIDIA GPU. It can be something like a GeForce 10 something will be able to run Rapids. And then you start with the code you already have on PyData. The first thing to do is to migrate this code to Rapids, and then you'll be able to see a very significant speed up on your code, and check that it's been really distributed over all the computer resources we have on the GPU. But the real magic happens when we associate Rapids with Dask. That is another open source software. And what Dask does is basically he'll get the Rapids code and he'll distribute it automatically through multiple GPUs on the single node or through multiple nodes with multiple GPUs in a cluster. So without knowing all the details about synchronization, distributing computing, and complex things like that, you can start from a Python code that you already have, accelerated using Rapids on the GPU, and then really accelerating it through clusters and massive parallelism using Dask. It's really easy to do, and everyone can scale their processing. And to scale this kind of processing, it's really important because typically we start data science workloads and projects with a certain amount of data. And this amount of data typically will grow a lot over the next years or months. So assuring that I just need to add more nodes to increase my computing power without need to rewrite all my code, it's really important to scalability. Also, Rapids can integrate with other deep learning tools through Apache Arrow that I explained. So with that, we can really optimize the data sharing inside the GPU memory, and we are able to really do a very good speed up on our pipeline because most of all the pipeline are being running inside the GPU. So with Rapids, we leave a scenario where I spend a lot of time just waiting for the code to run and then discovering that I missed things and so on to a space where I'm really productive and building more. I know cases of training that used to take like 15 hours, reduce it to 15 minutes using Rapids. And there are several cases documented all over the internet about it. Just to give you an idea who is using and adopt Rapids today, basically 25% of the Fortune 100 companies are already using Rapids. We have more than 100 open source and commercial software integrations with Rapids, and much more than 350 contributors on GitHub. Those are some logos of companies that are using Rapids, and we really have a big community around it. One of the cases that I really would like to highlight is the usage Walmart does with Rapids. Basically, they used to process a lot of data, and one of the things they achieved, it's a 1.7 percentage point improvement in forecast accuracy on what will sell on each one of their North American USA stores. So with Rapids, they were able to deliver 100 faster feature engineering and 20 times faster model training within Rapids, Dask, and XGBoost. So we are talking here about a huge amount of data, and the result of this kind of processing has a big impact, economically speaking, on companies and organizations such as Walmart. After talking about data science, I will start talking about deep learning. And the first framework that I would like to present to you on NVIDIA, it's a framework called TAO. That is an acronym for train, adapt, and optimize. And this is exactly what TAO does. So creating an AI application can be hard and complex. And basically we start getting open source models from model zoos we have all over the internet. Those models are okay, but once I need to run this model on a GPU to get acceleration, I need to do a lot of adjustment on the model, and I need to do a lot of pre-training on this model to get it really optimized for the GPU. This could take a lot of time, efforts, and investments to do. So what I did at NVIDIA is that we now offer for free more than 100 combinations of models that could go from generic things such as image classification, object detection, segmentation. They are all based on the key and most important architecture used today for neural networks. And we optimized those models not only on the structure, but also on everything else related to do the best performance possible on a GPU. We give those models for free. But we also trained some models to achieve specific tasks, such as people detection, gaze detection, facial landmarks, vehicle classifications, automatic speech recognition, and several others. So when you start a project, you don't start with a generic model. You start with a model that is already optimized for the GPUs. Then you use TAO toolkit to train, adapt, and optimize this model. Basically, you do the transfer learning and train the model based on your existing data set. And the good thing of having this model inside TAO is that your production model can be generated according to the GPU that we use for the inference. So imagine that I have a model to recognize people on a people counting solution that I will run on a shopping mall. On my customer A, I need to run the analytics on an embedded device that will be close to the camera because I don't have bandwidth to connect to the cloud. So in this case, the model needs to be really optimized to run on an embedded device, such as Jackson. But on the other customers, they have their own data center inside the shopping mall, so I can put a server there. And then I will use a different GPU on the server, so I can optimize for this GPU. On my third client, my third customer, they have a very good infrastructure on a cloud provider. So I'll just stream the data, the video, and process everything at the cloud. So I can also generate the best optimized model to this environment. So using TAO, you are sure that you are starting from the best reference model, trained and optimized for GPU, and some of those models were trained like 100,000 hours on clusters of GPU, just to illustrate the amount of effort we put on this. So we start with a model, really optimize it, you do the transfer learning, and then you can generate the model to be consumed by your application according to the hardware that we're gonna use. And as I said, edge to cloud. Those are the key frameworks that we have for inference, DeepStream, Riva, and Triton. I will talk about some of those in a few minutes. TAO has also characteristics of doing training optimization, so it can run on a multi-node, multi-GPU node, and multi-GPU with multiple GPUs. It works with automatic mixed precision, and on inference, it can also do the pruning, which is removing nodes from the neural networks that are not being activated by this particular training. And also quantization, that is basically adjusting the weights of the network according to the hardware that will process it. When you use those two things in combination, we can achieve up to 4 times speed up for inference, which means that we can really have very well optimized applications. One of characteristics of TAO that I really enjoy, because I work a lot with computer vision, is that TAO can do data augmentation online. So data augmentation on computer vision is basically a technique where I have a very limited data set. I can't have more images on this data set, so I do something that I used to joke as the miracle of multiplying images, where we just apply some image algorithms to generate 4 or 5 images based on a single one. This could be rotating, adjusting brightness, and several other manipulations that we do. But when we do this on the traditional way, I need to pre-process my data set, and I need to have a lot of space because my data set will become really huge. What we can do with Tau is that once the image is on the GPU memory, it's very, very easy to apply those image algorithms to do data augmentation. And we can do this during training, which means I don't need to expand my existing data sets. I just use this feature from Tau, and online it will generate other images. And here we have some numbers. As you can see, 100 images experiment with 20x augmentation. We really achieve a lot of accuracy on both scenarios. So if you work with computer vision, please take a look on this feature for Tau. Some examples and use cases of Tau is like this one. I will start from a PeopleNet model. That is a model trained on RGB cameras, but I need on my solution to identify people on infrared cameras. So basically what I do, I start from the optimized PeopleNet model. I will do transfer learning with my annotated images from thermal cameras, and I will have a very good result and a working solution in a few minutes. Also, I can do things much more complicated. On this case, I need to have a data set where I recognize helmets and people and heads. So I don't have a data set with all those things. I will start from the same PeopleNet I mentioned before. I'll use a labeled helmet data set, and I'll generate a data set with annotations of people and face. Then I combine both things, and I have my final neural network trained. As you can see, I can achieve over 80% of average class precision after 100 epochs. That is a really short training when we're talking about deep learning. The newest versions of Tau has some very interesting tools. The first one is to help you to do segmentation masks. Just to illustrate, when you need to segment images, you need basically to paint the pixels that are part of a special class. In this case, I need to paint all the pixels that are part of bottles. But with this auto-labeling tool, basically what you can do is that we can turn bounding boxes on images on segmentation masks. The other thing, we are also providing vision transformer models that are revolutionizing everything we do in computer vision. Basically, vision transformer is the usage of the transformers technology from natural language processing and LLMs to computer vision. This is really interesting. It's open source, and you can deploy it on different type of platforms and hardware. We have tools for AutoML, which will help you to identify the best hyperparameters for optimize your training. It can be integrated with services using REST APIs, so you can build a whole solution around Tau. And as I mentioned, that when you use pruning and quantization, we can achieve up to 4x increase of performance during inference. Similar from Tau that we basically use for several different types of neural networks, we have NeMo that is specifically for training LLMs, large language models. Just to illustrate the complexity of this kind of processing, in 2018, the state-of-the-art model that we have had around 94 million parameters. We are talking today in models with much more than 1,530 billion parameters. GPT-3 has 175 billion parameters. So we are talking about huge models. And the training of those models is really complex because we need to have data parallelism. We need to use thousands of GPUs. This will be distributed on a cluster with a lot of computing power. And NeMo is the framework developed exactly for those use cases. We can do with NeMo the data curation, distributed training, and accelerated inference. It has the key features to help you to build and to customize your LLMs, large language models projects. And we also offer NeMo guardrails that is open source. And guardrails, it's a very important part basically on chatbots, because they will be the boundaries, or they will limit the application to answer on a specific topics. This means safety for the users. and prevent hallucinations in executing third-party calls and increase the security. If someone asked some funny questions to ChatGPT ever, and you have say, hey, I can't answer this because this and that, it's the guardrails that are working. I used to say that if I went to ChatGPT without guardrails and say, hey, I have, those drugs in my home that I bought from a drugstore nearby, which ones I need to take to, do something bad to myself? He'll be able to answer this. But a guardrail said, hey, we cannot answer, and I believe you got the points. So Memo guardrails is also available open source as Nemo. You can use it and also contribute to build your large language model projects. Riva, it's one framework that we developed to do three things: automatic speech recognition, neural machine translation, and text-to-speech. Those are three very complex tasks on AI because you need to do a lot of steps on the pipeline of processing. We built Riva to do exactly that. So it's much easier to talk about Riva explaining the use cases. In this case, I have a customer talking to a contact center. I have Riva listening to the customer, converting this to text, using NLP and several other technologies to print real-time recommendations on the contact center agent screen and allowing him and helping him to do the right recommendations to the customers. Here it's another scenario that we, get used on the pandemics and also on several different tools that we have of videos online, where we can do automatic transcription, we can do automatic translation, we can do summarization, and everything else just based on video. This is where Riva really can be used. And when we have a full round applications is where the customers is interacting totally with computers. He's not talking with humans anymore, but he feels that he's been very well treated. In this case, it's a project from NVIDIA named Tokyo, that is a talking kiosk where you go there on a fast food restaurant and you start talking to this small robot. He will give you suggestions, he will recognize you, and it will be a very natural way of speak. Just to have you an idea, there's a lot of drive-thrus today all over the world that are changing humans on the other side of the microphone for technologies like this, and it's very adaptable and able to use on those kind of environments. Imagine that you have a lot of noise, you have different audio qualities, and Riva can handle all this. Riva use pre-trained models the same way that we talked about Tau. You can use Tau to retrain those models. And if you need to expand the model or do something more complex, you can use Nemo. Then you can implement all the three key tasks using Riva and implement your end application using this technology. Just to explain how we evolved or we growth over the past years, in 2018, we have like 45% error rate on automatic speech recognition. 2 years ago, it was less than 10, and it's still getting reduced. And also, we can have a lot of accuracy when we customize the models, because if I'm working with a model that will be used to have conversations with banks, customers, financial transaction customers, this vocabulary will be totally different of the vocabulary of a person asking for a hamburger on a fast food. So with Riva, we can adjust the whole model to be very specific to one kind of jargon or dialect or a specific set of words. This will increase a lot the accuracy. So Riva is our SDK for doing this. Triton is what I used to call the Swiss Army knife of inference on AI today. When we use an AI-based application, our application is talking to an inference server. And if I write my application to one specific inference server, let's say PyTorch, TensorFlow, or any other, and tomorrow my AI and data scientists discover that there is a new model based on other framework, other inference server that is performing best to my solution, I will need to write the end user application again. It doesn't mean if this end user's application it's on a cell phone, directly talking to an inference server, or if this application, it's, let's say, a Java application that is interface during the interface between all the AI pipelines and the end user applications, that can be a lot. So Triton is key in this kind of scenario, because you write your application to talk to Triton, and Triton can talk to all other major backends and frameworks for inference. So let's say TensorFlow, TensorRT, OpenVINO, PyTorch, Onyx, XGBoost, several others. So basically, your application is written to Triton. And then today, my data scientists said, hey, this is the best model we have. You need to run on TensorFlow. Okay. Tomorrow or 6 months, they say, no, now we have a model on PyTorch. I just changed the model on Triton configuration. I don't need to write the application again. Triton can communicate using HTTP, gRPC, and C++. You can do inference distributing on the different kind of hardware you have. It supports from bare metal to virtualization, edge to cloud. Different types of queries that are typical from different types of applications, real-time, batch, streams, and mixed models. And it also totally developed, focusing on maximized hardware utilization, which means reducing the total cost of operations of your solution. It also has integration with Kubernetes, with its scalable microservices. It's very easy. We provide these all those things for Triton. It is integrated with the key practices and also some tools of machine learning. So basically with all the tools from cloud provider, Azure, AWS, Google, and so on. It supports live model updates, dynamic model loading, which is really interesting because I just load the models that I will use on a particular transaction, and several other tools that will help you to optimize your operation, and MLOps guys will love it. And also we have, it's all open source and customizable. You can change it to adjust your needs. This is an idea of all the frameworks, formats, and models it can has on execution backends. This list is growing more and more. It's very, very flexible. And in a nutshell, Triton is what put together everyone working with AI applications and also end user applications. So for data science, we can use any framework. For people working with maintaining those models, working on inference, the models can be on any repository and it can be deployed on any platform. So Triton is what really brings you flexibility to work with all those kind of AI applications. The next framework that I would like to talk is Isaac, because robotics are really growing today. We are having robotics boosting every industry. I know that in Europe, we have cases of automatic delivery, even on small stores in small cities. And also we have this kind of applications on different areas, retail, logistics, manufacturing, and so on. But to build AI in robotics at scale, it's really hard because it's hard to develop. Here we are talking about developing the software, the AI, and the hardware in parallel. It's hard to test, and it's really, really hard to deploy. So this is why we created the Isaac Robotics platform. That is basically a platform made by a simulation component, a key SDK training component, and a deployment part. So to start the development with Isaac, I start with a simulator where I will import all the projects that I have for my physical robot. I will create a virtual world where this robot will operate. I connect it with virtual sensors and actuators, and I'm able to start programming and training all the AI inside this virtual world. When I'm done with the training, I use the Isaac SDK to develop all this. I just need to move the code from the training with Isaac SDK to the physical robot. So this whole cycle really, really speed ups the development, and it's very useful in situations such as one very good case that we have with BMW, that they need to train robots to do pallet movement on a very specific area of the factory. They couldn't stop the factory just to train the robot on that area. So they used LiDAR and photogrammetry. They created a digital twin of that area. They imported the projects of the robot they're going to use from the supplier. They trained the robot inside this digital twin on several thousands of hours. And when they are okay with the results, they just validate it on the real world. And for the robot that was trained with photogrammetry and real 3D images, it doesn't matter if he is on the virtual play environment or if it's on the real world. So Isaac is very, very useful for that. The other framework that I think it's very important for NVIDIA, it's part of a bigger platform actually named Metropolis. Metropolis is a platform for us to build smart spaces and infrastructure. When we see what is happening with AI today, real useful AI solutions, computer vision solutions for the existing world, the real world, are not developed by one single neural network, but for the concatenation of the results of processing of a lot of different kinds of networks on the same system. It doesn't matter if it's smart cities, factories, public spaces, retail, anything you use. You need a platform to really cross information for different kinds of neural networks. This is one example app developed by one of NVIDIA partners using the Metropolis platform. Here we can see that they are analyzing images coming from drones, fixed cameras, and several different types of cameras. They are measuring and counting cars, people, bikes, and several other kind of things moving in the city. This tool that they developed allow the operator to configure and to parameterize any kind of alerts he really wants to have. And as you can see, here we have hundreds of neural networks working in parallel and giving information to a single platform that is able to consolidate everything. This is exactly what Metropolis is. It's a platform, a framework for smart sensors where you can use, and this is being used actually on retail, traffic management, logistics, healthcare, manufacturing, factories, several other applications. Under the hood, what I have are those pre-trained models that I mentioned to you on the beginning of my talk. We also have TauToolKit that now you already know what it is, and DeepStream, what I'm going to explain to you. By the way, everything that I'm talking here is available through one website that is ngc.nvidia.com. On NGC, we have more pre-trained models. We have containers for all NVIDIA SDKs, and the coolest part, we have containers for other SDKs such as TensorFlow, PyTorch, with everything optimized for the GPU. So all you need to have a TensorFlow running with everything optimized for an NVIDIA GPU is to run one of those containers. If you are using a cloud provider, some of the containers you're going to find inside the marketplaces, and also you're going to find virtual machine images from NVIDIA on those places that can be used to launch the containers and to pull the containers directly from NGC. Computer vision is much more than AI inference, because to every frame, we need to capture and decode the data. We need to pre-process the image and sometimes do the batching. Then we do inference, tracking to not count the same object twice, for instance, send this metadata extracted to other systems, finally made in a composition. Typically, developers use a GPU acceleration just here, and they do all the other parts using things like OpenCV running on CPU. And then we got on that situation where I have a lot of data back and forth from the computer run memory to the GPU memory, and I'm not using an optimized pipeline. This is exactly what we can do when we use DeepStream. DeepStream can use the best acceleration it possible on each part of this processing. It supports run from edge to cloud, and it's very flexible. And why this is so fast? Because we just get the data on the beginning of the pipeline, and then we process everything almost with zero memory copies. So the buffer is the same. We just pass to the other part of the processing a buffer to the same place on the GPU RAM memory. And this is the fastest way of processing this kind of frameworks of workloads. We have also the opportunity to get data right from the camera buffer using a networking technology for NVIDIA called RiverMax, where I can put an industrial camera, I can extract the raw stream from this camera directly to the GPU memory, increasing even more the performance of my solution. We can use DeepStream, we can program DeepStream using Python, using C++, but it's also a composer. That is a tool where I will just drag and drop some blocks and build graphically my application. On the end of this whole process, I will generate a container and I can deploy it anywhere. I will use the models that were pre-trained to Tau. We can also import Onyx models to Tau and optimize them to use this way. And if I need to use any other model, I can just use Triton with the proper inference server, and DeepStream can communicate with Titan using a gRPC. The other cool thing is on-site detected metadata from the video that I'm analyzing or the images. I can send messages with this metadata to Redis, MQTT, Kafka, and several other cloud providers, IoT protocols. Okay, so after I package this whole thing that I developed, the whole solution, I will have a container I can deploy anywhere. For the people that work with computer vision and knows a little about it, this is basically a set of plugins for GStreamer. So being a set of plugins, it means that I can reuse a lot of my code from project to project, sometimes just changing the type of networks. If I need to count people on this application and cars on the other one, basically what changes is the neural network. I change the people detection to a car detection, and the rest of my application, the core of my application, is already written. And what we see in practice, and I'm able to work with more than almost 700 startups in Latin America directly, and I'm seeing this in practice. The startups and the companies that adopt those technologies speed up the development time up on 10 times, because it's much more easy and productive to work with all those frameworks. Metropolis allows developers to develop things like smart spaces application, where I have several different technologies and neural networks, and I can put all together on a single system. To end my talk here, I will talk about Omniverse. That is new era of collaboration and simulation. Virtual worlds are essential for the next era of innovation. We truly believe that everything that will exist on physical world will exist on a virtual world first, because it is the cheapest way to build the thing right for the first time. We built and use Omniverse to our own applications. So we have AC, that is the avatar technology. We use Omniverse for it. We have digital twins of several cities, where we use those digital twins to train NVIDIA Drive Sim technologies, because inside the digital twin, we can generate events that we can't in the real world, so change the weather or cause collisions, traffic, and other conditions. Isaac Sim, that I mentioned before, is already integrated with Omniverse, so I can create digital twins of small stores up to huge places. And also, we are developing Earth 2, that is a hardware and software infrastructure that we're going to work with researchers. And this is basically a digital twin of the planet Earth to study the climate changes impact and several other things. Omniverse, it's the tool for two basically scenarios. The first one is 3D creation and collaboration. The second one is to create industrial digital twins and to operate them. When we're talking about 3D design, it's really complicated because we are talking about large teams with different skills, which means different tools, which means different kind of files to integrate to build a pipeline. And we need more and more accuracy on the end results of 3D compositions. So those workflows are rising in complexity. We have a lot of challenges today. People are working from different places in the earth. Sometimes we are talking about 3D data sets that can't be moved from a place to the other because of their size. And also, it's really important to have a single source of truth because most of this work is done linearly. So this person here create an initial idea of a character, and then this one make it more detailed. This one put some polygons and implement it. This one put all the skeleton, and the last one here start doing the animations. Imagine what happens if this guy get the wrong version of this one, and they will just discover it on the end when everything's built together. So having a single source of truth is really important. Omniverse can be has what we call nucleus, that is a central server where everyone can work together using the key technologies from NVIDIA over the past decades, and they can act and interact in real time. So everyone can be on the same place, virtual space, each one doing its part of the work, and everyone see what everyone else is doing. And when we are talking about digital twins, we can create the digital twin, and we can operate this digital twin doing things like robot training, digital human training, factory planning, operation simulations. And this is all done basically on real world existing assets. Let's say the CAD files for the factory itself or for the robots that are operating there. So basically, we go from the real world and we create everything on the virtual environment. Here we have an example of two people working together on Omniverse. On this side, I have a person working, creating an area that is this kitchen on a specific tool. This is not Omniverse, I think it's Revit. And on the left side, I have someone working with Omniverse Create, putting texture, lighting, and so on. So as you can see, every change one professional does to his part, it's automatically translated to the other one. Here we have someone working on the architecture of this lighting stuff, and someone else doing the lighting actually and the illumination and all those things. And we have here on the right side an image that, let's say, our art director can be seeing and giving feedback on real time. This is good, this is bad, change this, change that, change the lights, change the structure, almost in real time. Without Omniverse, this is back and forth linear process. Here we have 3 people working, putting assets on a kitchen for one specific demo. And here we have an art director or a project director just giving feedback in real time so they can see the changes all other people are doing. Those are the basic components that is part of Omniverse. Nucleus, that is a central repository. Connect, that allows you to connect to several other applications. Kit, there are a set of reference applications, basically in Python, to allow you to interact and to use all these simulation technologies and also RTX renders. It's just possible because of the universal scene description. That is a file format and a file framework that is the HTML for 3D virtual worlds. It was created by Pixar because Pixar has a very complex data building and asset building pipeline. And they say, hey, there's must be an easy way for us to integrate all these. So NVIDIA embarked working this with Pixar. There is now a whole open structure and open association to evolve OpenUSD today. Basically on Omniverse, when you have an image like this, This image is based on different assets that are like layers, and each of those assets were created with a different tool. So without Omniverse, without USD, it will be really hard to integrate everything on a single experience. Omniverse is not a tool, it's a fabric with a huge amount of tools ecosystem. This slide is outdated because it's really hard to keep it updated, but it gives you a very good idea. Here are some of the software partners and the early adopters of Omniverse. Omniverse can be automated and extended using Python. So I used to explain Omniverse to developers as imagine a Python frameworks that can build metaverses and virtual worlds and virtual things for you to explore. There's a lot of open source involved with this. You can just download Omniverse, check one of the extensions, and start working with them. Inside Omniverse, we have physical simulation using all NVIDIA technologies, so we can replicate the real world rules, physical rules, to the virtual world. We also have a render, and you can use external renders too, but it's very well developed to be scalable. So when we have complex workflows, we can distribute this to clusters, real-time, photoreal, physical, accurate, and base it all on open standards. This is a short video of the BMW's Factory of the Future. I invite you all to go to YouTube and check NVIDIA Omniverse Digital Twins. You see a lot of very good examples of videos and projects. And sometimes it's hard to say what is real and what is virtual using this technology. To finalize here, I would like to leave you 3 key links to learn more about all those things. Developer.nvidia.com, just go there, register yourself. Forums that really works because the framework developers monitor those forums. We have a lot of material to learn and to know more about NVIDIA, including some training. Inception program, that is a program to engage startups all over the world. We have more than 15,000 startups all over the world. I'm responsible for almost 700 here in Latin America. And we are really helping startups to innovate with AI and hardware GPU acceleration. And also NVIDIA On Demand. I would suggest to everyone on NVIDIA to change this to Nerdflix. But the idea was not accepted yet. But this is basically what it is. So on each event that we have annually, that we'll talk about in the next slide, we generate like 400 talks of content. Everything is uploaded to this portal. So if you need to learn anything about NVIDIA tools and software and use cases, you just go to NVIDIA On Demand. You can log in using your developer account, and you are able to access to all the content we already generated. March 2018 to 21, we're going to have in San Jose, first time presential, actually hybrid after 5 years. We're going to have the GTC, that is the biggest technology conference we have on NVIDIA. I really recommend you all to register now. Just scan this QR code. You will be on a link where you can register for free for the online event. But also, if you want to attend in person, with this QR code, you can have 25% discount on your tickets. I would like to thank again to Otavio and Fabio that invited me to be here with you today. Thank you for all your attention too. If you want to contact me on social media, this is the easiest way. You can find me everywhere from LinkedIn to Twitter using this. Thank you very much. I hope this was useful for you.
Thank you, Jomar. Yeah, it was really amazing, and thanks a lot for that. I think that the viewers really understood how to accelerate their AI applications using NVIDIA SDKs. I think it was an insightful presentation for all AI, Gen AI, DevOps, cloud native aficionados, and enthusiasts. Yeah, I think
just one last insight. I know it was a lot of content, but in a nutshell, what I would like to say is 10 years ago, when we're going to start to use GPU acceleration and AI, you really need to know a lot of parallelism, process distribution. It was hard. Okay, so we create a lot of abstraction layers that today it's really easy for any developer to start working with these technologies. This is not rocket science anymore, and I really recommend you guys to explore because there's a lot to be built.
Yeah. I really agree with you, and I know that some of our engineers are also here, so I think that is amazing for them too. And yeah, and thank you again for that. It was a very lean and illustrative presentation that I liked, that bright aspects that you want to highlight and to dive in. So thank you for that. Thank you for your time and for your kindness to be with us today. And while we are waiting to see if you have some questions from our viewers, as I told you before in this live stream, we have a final interactive segment where each speaker must answer a question from the previous speaker and do a question for next one. And the question that our previous speaker brought to you and you need to answer is, it's not related with tech, but would you rather give up social media or eat the same dinner for the rest of your life? So I think that I know your answer, but because I think that
I will quit. I will quit social media. You know, my Twitter account is for 2006.
Yeah, okay.
So I was using Twitter when we receive SMS messages on feature phones. So I started almost back there, and a lot of changes over the past. I don't think it was so. Oh, thank you, Otavio. I don't think it's the same place it was in the past. But I have a question for the next one. How Gen AI, how generative AI changed the way you work?
Oh, amazing. And I think it is a very good question because I already know who the next speaker will be. So I think that fits like a glove in him. So yeah, question. I will let me just point that and just to ask the question to our next speaker. And I think there is no questions, and I think it is, maybe it's a good thing because your presentation was as insightful as it can be, it could be. So that said, and thank you for your presentation. Thank you for being with us today, and I hope that you also enjoyed it. And for the our viewers and for our ex-biters, not a goodbye. See you in March in the third edition of this live stream. And of course, Jomar, you are invited to participate in our next live stream, not as a speaker, but as a viewer. But maybe next time you can be a speaker again. So thank you, Jomar.
Yeah.
Thank you to be with us.
One last thing, guys. If you need to send me any questions, please send me on Twitter. I will not talk that X because I hate this name, and also on LinkedIn. Okay, just send me your questions on LinkedIn. I answer to everyone there. Thank you so much for the opportunity. I really hope to see very, very great AI applications come from you guys.
As far as I remember, your social media name, Omenbyte.
Omen Beach.
Omenbyte, exactly.
Yeah. Okay.
Let me just Omenbyte, just to be here for everyone that wants to, like this, I think. Omenbyte, exactly.
Yes,
here in the comments.
exactly.
Yeah. So if you want to contact Jomar, please do so in their social media by Omenbyte. So thank you again, Jomar, and see you next time. Bye bye.
Thank you so much.
It was a pleasure. Bye bye.
Pleasure.